when we multiply equal whatever it is, and what's the unit? Inch, centimeter, cube?
Centimeter.
Centimeter squared. Oh, this is now well done. Thank you for this task. Just a second. So look at it. Now you apply the area formula to find the areas of different shapes. But our lesson is not about the area. Our lesson is about the volume. And who has an idea? I think you heard about in English about this volume. What do you mean by that volume? Yes?
I'm talking, I just want to think outside.
Yes.
Can we make it more realistic? Yeah, this thing. Maybe in my case, I have each fourth way.
Yep.
Here, two king, yeah, two king. They have on their.
Sorry, this issue now, this issue is out of our, it's
Yeah,
out of our, at the end,
just
okay,
leave it, yeah.
at the end of this, I can ask you. Let me finish now. I want now to make full procedure, make my procedure, the starter, procedure, and beginning, and the end, just to see how can I divide the timing of my lesson. Okay? So this is the volume of the prism and cylinders.
What do you mean by?
Okay. Yes.
What do you mean by volume?
What's the meaning of volume?
I don't know.
What's the meaning of volume? Exactly. Exactly. It means how much this 3D shape can be filled. The amount of space that it can be filled. For example, I have something here. Look, I want to show something. This is about 3D shape. It means a figure. Yes, it has an empty space inside. We can fill it. And to measure how much we can put, for example, water, gas, whatever, you have to use a unit, square or cubic. It's cubic unit, power 3, because I'm dealing with 3-dimensional figure. I have, this is a figure. 3-dimensional, I mean, there is, for example, I consider if I hold it like this, so this is the base of this figure, and this is the height. Sometimes it can be like that. So this is the base, and this is the height. So I have now how many dimensions? 3 dimensions. So because I have 3 dimensions, so I have a volume here. I have a volume. I can fill something. But suppose now I have like this one. So I have how many dimensions? 2 dimensions. So if you want to fill it, it's not impossible. No place, no space to fill it. So the volume is used for 3-dimensional figure. And for this lesson, I'm going to use 2 famous dimensional figures. One of them is the prism, and the second one is the cylinder. So I can make this one now 3-dimensional figure like this. Now I have three dimensions. If I place this figure like this, I have the base and I have the height. And it's regular. Why it's regular? Because the bases are congruent. The bases are congruent. I don't have actually here a cylinder, maybe, but I can represent this. What is a cylinder? What's the difference between this prism and this cylinder? There is one difference. What's the one difference? What is it?
Yes.
The bases. What's the shape of the base here? Circle. But here, it's a quadrangle. It might be a square, or it might be a rectangle, or a triangle. And this is provided by Ms. Basma 1 week before, and it's about lepton. Yeah, and this is a triangular prism. And what's the base here? So one question please. Can I represent it like this? This is the base and this is the height. This is the question. This is the base and this is the height. Who agrees with it? You agree? Who else? You agree? Okay. Actually, who disagrees? Okay. Actually, we cannot consider this is the base and this is the height. Because the base, it has to be 2 parallel bases. In this case, I have one base, but I don't have another one. So I have to know how to place this figure. So 2 parallel bases, so this is the proper position. So this is the first base, this is the second base, and what's the shape of them? Triangle. And this one represents the height of it. In general, okay, till now I know what's the meaning of 3-dimensional figure. I know what's the meaning of bases and the height of it, but I need the formula. How can you evaluate? How can you do it? Actually, for the prism and cylinder, the famous and the only formula we can use here to find the volume of any prism or cylinder, the volume equal, always find the area of the base, whatever it is, B times the height h. This is for rectangular prism and cylinder. Now, yes, the area of the base. B, it means not only base, the area of the base. The area of the base. For example, look at this shape. Can I place this one, this figure like this, and I consider these are two bases? Yes, it can be wide. This is actually rectangular, yes, rectangular prism. Can I keep it like this? Also, like that? This is a rectangular prism. Okay. Sometimes we have two kinds of prisms. The first one is the, yes, look at here. The first one is the regular prism. And the second one is the oblique prism. It means the edges, the lateral edges of the faces are tilted to the base. It's not perpendicular like this. This edge is perpendicular to the base, forming right angle, 90 degrees angle. But this one is little bit, it has a slope. Each edge it has a slope. But for any case, the distance between the two bases is the height. Of course, this is the height. And here, the height, it's not the edge, because this is a distance. And the distance is a straight perpendicular line from a point to the segment. Is it? Good. So this is the height, and this is for, so it's a general formula for any regular polygon prism or oblique prism. Okay? The idea is finding the idea is, or the formula use base times height. Whatever the base, find the area of the base, then times the height. And there is a condition here, must be both using the same units. If it's meter, centimeter, centimeter. If it's meter and centimeter, convert from one to another. It doesn't. Clear? So here I have this 1, 2, 3. May I ask you now, each one of you, please find the area of the first task 1. Task 1, please. Task 1.
Mister, do we have to write the forms?
Whatever, yes, I like that.
Form.
If it's done, please raise your hand. Raise your hand.